Saxon Algebra 1, Lesson 90. We're in a new decade of problems. It's very exciting. We are making great progress in our book. And today we are going to do some word problems that are a little different than ones we've done in the past. We're going to be building systems of equations. So we'll have two variables and we'll have two equations, and we're going to have to pick them out of the words. What we'll be looking for as we read the problem is two statements of equality. Now that sounds not like a thing a normal person would say. We're looking for two sentences that tell us about things that are true. So let me read you the first one. Together, Charles and Nell picked 92 quarts of berries. So we have two people picking berries, and together they pick 92 quarts. What my brain does with that is that the number of quarts that Charles picked plus the number of quarts that Nell picked equals 92. Together, Charles and Nellie picked 92 quarts of berries. That's how I turned that sentence into an equation. Now, the next one is not going to be a value statement like we did with our coins or our dresses or our super cheap airline tickets. The next one is what I call a balancing statement, and it goes like this. If Charles picked 6 more quarts than Nell picked, how many quarts did each of them pick? If Charles picked more quarts than Nell, see how I leave the number out? That helps me write, if Charles picked more quarts than Nell. That helps me write an inequality. I'm not done, but this is the best way to write what I call a balancing statement. Statement. Okay? We write first as an inequality, and then we use the special number to balance it. If Charles picked 6 more quarts than Nell, 6 is the balancing number because it's right by the word more. If Charles picked more than Nell, then we see the greater than means that this is the smaller side, so I'm going to add 6 to turn it into an equal sign. This is the hard part. And students often get this wrong because they add the 6 to the wrong side. Because it says Charles picked more. Charles had 6 more quarts, so it seems like you should take Charles and add 6 to it. But that doesn't make it balance. This is the way to do it. Write it as an inequality first, and then use the number to balance the inequality. Okay, now we have a nice little system, and it's going to be super easy to solve because the hard part of these problems is setting them up. What I'm going to do is I'm going to substitute because this one's all set up to substitute. There are the two NC's. So I'm going to plug this into this, and I'm going to say the number that Nell picked plus 6 plus the number that Nell picked, right? This goes in here, and then I have that equals 92. I didn't need these buckets. I just used them to show you that's what NC turned into, the number that Charles picked. Now I'm going to subtract the 6. At the same time, I add these like terms. 2 times the number of Nell picked equals, what is that, 86. And that means that the number that Nell picked is that divided by 2, 43. And then I know that if I take the number Nell picked and add 6 to it, I'll get the number that Charles did, and that's 49. And if I played my cards right, these should add up to 92, right? 2, 9. Yay, it worked. So I don't go to the trouble of actually writing out the equation and plugging it in. We're kind of past that at this point. That's a quick little addition thing you can do in your head. But I like to show this number down here, which shows, oh look, it does work. It's just a way of showing that I've double checked my thinking. All right, there's one example of these problems. One thing I will tell you is that we're gonna do 5 of these problems, which seems like a lot. They'll go pretty fast though. The problems that you get in the homework will probably match quite closely to one of these 5. They're word problems, so the story, the way the facts are laid out, you can probably find in your notes a problem quite similar to it. So even though that's a lot of examples for us to do, it may help you with your homework. The number of boys in Sarah's class exceeded the number of girls by 7. Ah, there's our balancing statement. The number of boys exceeded the number of girls. I write the inequality first, and then I use the balancing number to turn it into an equation. The number of boys in Sarah's class exceeded the number of girls by 7. That means I need to add 7 to the smaller side, which is right here. Now, I think I've told you this before. I like to always put the change on this side because I have more room to write. In this case, this one's bigger, this one's smaller, so I know I need to add 7, and then that changes it to an equal sign. This is exactly the way I want you to write these. Write the inequality, fix it, and then just write the equal sign over the top. If there were a total of 29 pupils in the class, how many were boys and girls? Oh, well, the number of boys plus the number of girls equals 29. Now this is all set up for substitution, and I will do that. So I'm gonna plug this expression in right here. So I'm gonna say the number of girls plus 7. I'll put parentheses around that just to help you see that's what is now the number of boys. Then we do this, plus the number of girls equals 29. And then we can do 2 steps at once. I will add those 2 at the same time I subtract the 7. Where are you going? Oh, right. 2, sorry, just directing traffic in the house. And so, the number of girls equals 11. And then the number of girls plus 7 equals the number of boys. So I just add 7 to that, that's 18. This should be my answer, but let's just double check. This adds up to 29, and yes, that's exactly how it should. In some ways, these problems are easier than the coin and coin-ish problems that we did because we don't have to do the distribution because we're not multiplying these by anything. Like, you know how we multiply the number of quarters times 25? We don't have to do that kind of multiplication in these. So they're easier in that respect. Philip cut a 38-meter rope into 2 pieces. Okay, I'm just going to visualize this for you. There's the rope, and he cut it into 2 pieces. The long piece was 9 meters longer than the short piece. Okay, let's call it the long piece and the short piece. Let's not use subscripted variables this time. Let's just use L and S. So together they make up 38. So the long plus the short equals 38. But we know that the long piece is 9 meters longer than the short piece. So the long piece is greater than the short piece. That means the balancing number, we have to add to this one. The long piece was 9 meters longer than the short piece. So that's how we balance it. Those balancing statements, you guys, they're tricky. They are tricky. I've taught them a number of different ways, but writing it as an inequality is by far the quickest, easiest way to get it right. Okay. So now, we'll plug in once again. So it'll be S plus 9 plus S equals 38. Subtract the 9. At the same time, we add the S's. That's 2S equals 29. And then divide both sides by 2. And in a fairly unusual move, John is giving us a fraction. That's what I was just thinking about, making sure that was right. The length of the shorter piece is, let's see, half of this, if it was 28, it would be 14. So this is 14 and a half. I was just mentally doing this. If it was, another way to do it is if it was 30 over 2, that would equal 15. If it was 28 over 2, that would equal 14. So because it's in between that, we know it's 14 and a half. And then the long piece, we know we take that and we add 9 to it. So that's 23.5. There's my answer. And then let's just add it. 0, 8, 3. There's the 38. Yay. It's quite unusual for John to make these numbers not come out even, to have a decimal. And I could have written this as 29.2 over 2 is the answer, but adding 9 then would have been a little bit trickier. So for me, it was easier to switch it to a decimal. This is how John shows the answer, but if you wanted to show it in fraction form, that wouldn't be wrong. 90.4. The sum of two numbers is 72. Now, again, you have a lot of room to make up whatever variables you want. I'm going to say number 1 plus number 2 equals 72. The difference of the numbers is 26. So I'm just going to write n1 minus n2 equals 26. Now, some students might look at this and go, how do we know we're setting this up so that the bigger number goes here and the smaller number goes there, right? In subtraction, that's how you want it to be. And my answer to that is the way we're using the variables here, it's all going to work itself out. We don't have to plan for that. We'll just set it up like this, and you'll see it'll all sort itself out. But to a certain extent, just write the equations to follow the sentences and don't overthink. I would say overthinking is the biggest enemy of these problems, all right? So don't worry about which one's the bigger, which one's the smaller. It's fine. This is perfectly set up for elimination, isn't it? So I'm going to write 2 times the first number, because that cancels, equals, what's that, 98. Divide both sides by 2. And I'm going to go up here. N1 equals, what is this? It's not quite 50, right? Because 100 over 2 would equal 50. So this must be 49. And then I know that the 2 have to add up to 72. So what do I add to make this be 72? I need a 3, and then I'll carry the 1, 2. So I did kind of reverse adding in my head to figure out that second number. You could just set up a subtraction problem if you wanted, but I chose to do it kind of sideways in my head. I was imagining 72 is the answer and going, okay, 9 plus what would give me a 2? 3, I'd carry the 1, then I would have 5 here. 5 plus what would give me the 7, and it worked. Yay! Okay, one more. The greater of two numbers is 16 greater than the smaller. All right, my gut reaction to this is to use a G and an S. The greater of two numbers is greater than the smaller. This is going to be my balancing statement equation. Okay, this example, we didn't have a balancing statement, did we? The greater of two numbers is 16 greater than the smaller. So I have to add 16 here to make it balance. When added together, their sum is 4 less than 3 times the smaller. Okay, this is confusing. When added together, so G plus S, their sum is less than 3 times the smaller. When added together, their sum is less than 3 times the smaller. Okay, so I wrote the inequality. The balancing number is 3. This is the first time we've had the inequality pointing in that direction. That tells us that this is the smaller number, this is the larger number. So to use my balancing number, I'm going to subtract 3. I'm subtracting because this is already the bigger side. So if 3 is the number that makes it balance, then I need to subtract from this side. You could also add to this side. That would be another way to balance the statement, but I don't like to change the part on the left because then I'm squeezing numbers in and that just annoys me. So I put it over here. All right, there's our system. This is G equals, so I'm going to substitute this G for this G. This will go into this. Oh, I need to change that to an equal sign. Oh. These were both balancing statements, weren't they? Goodness, that was a lot of work. Okay, so this goes in here. S plus 16 plus S equals 3S minus 3. My S's look like 5s. It drives me insane. Let's swim. I see this 3S, and I see there's 2 here. So let's subtract both of these S's, and I'll write it as minus 2S here. And then let's add 3 to that side. Wait a minute. Their sum is 4. This balancing number should be 4. Let me show you what I did wrong. It said 3 times this. The balancing number is 4, not 3. So I wrote it wrong in all those places. Oh. Let me start this one over so that you see what I'm doing. I just copied the number wrong and it just made a big fat mess, and I don't want to have a big fat mess. Okay, our 2 equations were the greater of 2 numbers is 16 greater than the smaller. The greater is larger than the smaller. We add 16 to the smaller to get it to balance. When added together, their sum is less than 3 times the smaller. The balancing number is 4. So their sum is 4 less. So I have to subtract 4 from the side that is larger. Now they're equal. There. I just had this the wrong number before. Okay, so we're going to substitute this into this. there's the expression that's going to become our new g. So we write s plus 16 plus s equals 3s minus 4. And I'm going to show an extra step this time. Let's clean this up. It's 2s plus 16 equals 3s minus 4. So let's add 4 to swim the plain fishies this way, and then we'll subtract the 2s to swim the s fishies to the right. So we're doing 2 swimmings at once. That cancels, 20 equals s. Oh, okay, beautiful. And that means the greater number, we take the smaller number and we add 16 to get the greater number. So 36 equals the greater number. And that's the right answer. Oh, there's one more. My goodness. They just keep going forever. Example 90.6. The ratio, oh, this is a good one because it feels so hard at first. The ratio of two numbers is 5 to 4. How do we write that? Just remember, a ratio is a fraction. So we can write first number, second number equals 5 to 4. Making the words turn into that is a big mental step. Let me read it again. The ratio of two numbers is 5 to 4. A ratio is a fraction. So we create it first with letters and then we put in the numbers. And the sum of the numbers is 63. That one's pretty easy. No balancing statements in this, but this whole ratio thing is confusing. Just remember a ratio is a fraction, and that will help. All right. Now, how are we going to solve this? We could substitute. It doesn't look like we're going to be able to eliminate because when we eliminate, we want the two equations to look really similar. Let's put it this way. No matter what we do, we're going to have to rearrange this, right? Because this isn't ready to substitute or eliminate. So let's start by cross-multiplying and see what we get. 4 times n1 equals 5 times n2. Okay, that looks better. Now, what if we what if we rearrange this? This we cross multiplied, right? If we change this one, now we can substitute that in there. It's a very unusual solving pattern that we're using here. We have to remember to cross multiply to get rid of those denominators, and then we're just going to rearrange this one to plug in there. We could have rearranged it for n2. Either way would be fine. Okay, so now I'm going to put these together, and I'm going to get 4 times 63 minus n2 equals 5 n2. Okay, so we're plugging this into this. Now I have to multiply. This is, let's see, it's going to be 240 plus 12. Add the 4 and 2. That cancels. And we're going to have to do some long division here, aren't we? 252 divided by 9. 9 into 25, it goes twice. 18, subtract 7, bring down 2. Oh, John, thank you. Turns out even, right? Because 8 times 9 is 72. I double rule, that means we're done. We finished. Okay, so N2 equals 28. And then I can subtract that from 63. Let's just do it the long way. 63 minus 28 is 35. And that's the right answer. Yay! Beautiful. All right, this ratio bit is tricky. Just remember, a ratio is a fraction. Okay, that is lesson 90. Please use those examples to help you with these problems as they pop up in the homework. If you're at all confused, check with these notes and find the pattern that matches in the examples. And I think that you'll get some really good help from your notes. Okay, lesson 90 is done. Thank you. Goodbye.